This video is a continuation of our 6.3a lesson, Special Angle Relationships. We left off on number 7. Now, number 7 is very similar to what we were just doing on numbers 5 and 6. They just make the shape look a little more complicated by adding these line segments at the very end. Our focus, however, is on these four angles right in the middle. So if we use what we learned in our last video, we can see that these two angles are vertical angles, and we know that vertical angles are congruent. We also see that these two angles right here, they form that nice straight angle again, which means that they add up to 180 degrees. So we can set up an equation, 129 plus we don't know, equals 180. Add the negative 129 or subtract 129 from each side, and we get x equals 51. So we find out that this angle is 51 degrees because it's supplementary to the given angle. And then to find this angle right here, we have two options. We can say that it is supplementary to the given angle, or we can see that it's vertical to the 51 degrees. So let's fill in our table. Angle FJI, so FJI, this guy right here, is 51 degrees. And since that's my very first one, I'm going to say it's because it's supplementary, because according to the table, I don't know this one yet. So I'm going to say supplementary to angle IJG. And then I have angle HJG. That's the next one it's asking me for. And this I have options. I could say it's vertical. I could say it's supplementary. So you can just pick one if you want. Supplementary to angle IJG, or vertical to angle FJI. And then we found this one because it was vertical to our given angle. So 129 degrees, and it's vertical to angle IJG. Now for number 8, they're going to ask us to grab a protractor and measure this all out. We're going to go ahead and save ourselves a little bit of time. I'm going to give you a few of the angles that are in here, enough so that we can do some future problems. So I'm going to tell you this angle right here is 61 degrees. This is 29 degrees. 29 degrees, 61 degrees. And this is 61 degrees and 29 degrees. Are we seeing a pattern here? 29 degrees and 61 degrees. I'm going to fix this degree sign down here. It's kind of bugging me. Look like a 0. There we go. And we're going to skip the rest of it. So let's look at our next vocabulary term. We'll come back to that diagram up above in just a moment. Our next term are complementary angles. So complementary angles is a pair of angles whose sum is 90 degrees. 90 degrees. So it's going to form a nice right angle or a corner. So if I were to give myself an example here, I'm going to take that right angle or a corner, break it up into two different angles. I'm going to put some labels on here. So point A, B, C, and D. And I can say that the measurement of angle ABC, that's this guy right here, plus the measurement of angle CBD, that's this one right here, will give us that 90 degrees. Now, just like supplementary, they don't have to be right next to each other. I could have one of my angles, oops, let's try to make that look a little better. I can have one of my angles, let's say up here, and maybe the other one way over here. And again, it could be flipped over or backwards as long as they add up to 190 degrees. So I'm going to write myself a little note here that they don't have to be adjacent. They don't have to be right next to each other. All right, so number 9 is going to have us play with that rectangle that we had up above. And they want us to find two angles that are complementary and adjacent. Something like this angle here and this angle here. Those two angles add up to 90 degrees. Now they also want us to come up with a set of non-adjacent angles. And this is why I gave you the measurements. So let's say I pick this 61-degree angle here. I could pick this 29-degree angle way over here. They're definitely non-adjacent. They don't touch, but they do add up to 100, or excuse me, to 90 degrees. So take a look at number 9, and I want you to come up with two of your own angle pairs. All right, so you could have different examples than mine. That's okay. There's lots of different possibilities here. Remember, adjacent, we want them right next to each other. They got to share a side. And non-adjacent, we want them not touching. So we're looking at those two and we want them add up to 90 degrees. Let's go ahead and flip the page. Number 10, consider a right triangle. What seems to be true about the two non-right angles in the triangle? So if we're thinking about it, and it says we can use these examples down here, we have a right angle there. That's what makes it a right triangle. And we're looking at these two angles. Well, when I look at those two angles, I see that if I were to add them together, they give me 90. And that makes sense because altogether it should be 180 degrees in a triangle. Well, let's see if this always works. Here's my right angle, so my non-adjacent, 34 plus 56 also equals 90. Here's my right angle on this one. Let's test it out. 81 plus 9 equals 90. Yeah, we are seeing that the two non-adjacent or non-right angles are complementary. Oops. So we're going to say, oh goodness, there we go. We're going to say the two non-right angles are complementary. And again, that makes sense because we know all of those angles have to add up to 180 degrees. And if one of them's a right angle is 90 degrees, the other two have to add up to 90 degrees. All right, so let's play with some missing angles again. As we look at these, we have to decide what's the relationship between the angles. Are they vertical, are they supplementary, or are they complementary? And that will help us decide what kind of equation we want to come up with. So for the next several, I'm going to help you with the setup, and then I'm going to have you pause it and actually solve the equation on your own. So let's look at the first one. I notice that these two angles together, we get that straight line or that straight angle. So I can see that these are supplementary angles. So my equation would be one of the angles x plus the other angle 32 all together gives me 180 degrees. So I'm going to have you pause this and solve it out. All right, so when we solve this, we get x equals 148 degrees. But now we have to answer the questions that are being asked. It asks us, what is x? So there's my 148 degrees. And then it says, what is the measurement of angle ABC? So angle ABC, they're talking about this measure right here, happens to be the same as x, so I'm going to put 148 degrees. All right, let's look at our setup for the next one. So this time I see that I get a nice corner here, or right angle, which means that these two angles have to add up to 90 degrees. That makes these complementary angles. And let's try to practice spelling this correctly. Complementary angles. So I know that the first angle plus the second angle is going to give me 90 degrees. All right, pause here and solve it for me, please. All right, when you solved it, did you get x equals 16? I hope so. So then when I go down here to fill in the x, I'm going to put x is the 16 degrees, and then it's asking me for the measure of angle ABC. So angle ABC, that's the same thing as X, that one right here. So again, I'm going to get 16 degrees. Now, sometimes they'll ask us for different angles, so we can't just assume that they're always going to be the same. All right, so let's look at this next one. Now, this next one, I see these two intersecting lines, and the two angles I have information about are directly across from each other. Across the street. Those are our vertical angles. So my relationship here is vertical angles. Oops, I said relationship. I started writing it. Let's write that again. All right, vertical angles. And I know that vertical angles are congruent, which means that they equal each other. They have the same measure. So let's go ahead and solve this one together. We're going to multiply each side by the reciprocal, or we can multiply it, or divide it by 9. So x equals 15. So down here, I'm going to fill in x equals 15 degrees, but the measurement of JGI, that's this one right here, this angle, that's 9x. So it's not 15. I have to go 15 times 9 to figure that out. That's 135 degrees. All right, let's look at this next one. I see this lovely straight angle, so that lets me know that these two are supplementary angles. So my equation would be 3x plus 2x equals 180. To do some solving, I'm going to combine my like terms. 5x is 180. I'm going to multiply each side by the reciprocal. Using my calculators, I get 36. So x is 36 degrees. And then it asks me for angle KLM. So KLM, that's this guy right here. So I'm going to go 36 times 3, because 3x, that gives me 108 degrees. All right, let's look at this next one. Again, these guys are across the street from each other. That means that they are vertical angles. And we know that vertical angles are congruent, which means that they will equal. They have equal measures. So to solve this, I'm going to add an 8 to both sides. So we're practicing our algebra, our equation solving. So I get 2x is 112. I'm going to multiply by my reciprocal, or again, you could divide by 2. And I get x equals 56. So there's my 56 degrees, and it asked me for angle RPQ. So RPQ, that's this guy right here. So I'm going to go 2 times 56 and then subtract 8. And I should get the 104. If I don't, I know I did something wrong, because those two angles should be congruent. All right, now looking at this next one, I have 3 angles that add up to a right angle. So this is 3 angles, so I can't call it supplementary, but I can say that their relationship is a sum of 90 degrees. So my equation, I'm going to take each of those 3 angles, and I'm going to set it equal to 90. So when I add 2x and x, that's 3x, plus another 3x, that's going to give me 6x. I'm going to multiply by the reciprocal, and I get x equals 15. So I can put 15 down here, and then it asks me for WUX. So WUX, that's this one right here. So I'm going to have to multiply by 3, and I get 45 degrees. All right, we're going to do the last page in the very next video.